Hello everyone, my name is Soumya Ranjan Das and in this video I am going to be discussing about the topic curve fitting. In this video we'll go through an overview of curve fitting, the types of problems in curve fitting, the method of least squares, general procedure used in curve fitting and one example. Moving on to the first slide, we'll discuss the overview of curve fitting. Curve fitting is a method to find the approximate relationship between a set of independent variables and their corresponding dependent variables. It is also known as regression analysis. Next, the method of least squares. Here, for different values of x, we find the approximate values of y. This is called empirical law. Suppose y is equal to fx is an approximate relation that fits into a given data comprising xi, yi, which is equal to 1, 2, 3 all the way to n. Then yi, small yi is called observed values. And then suppose there is another function capital Yi is equal to f of xi, then that is called expected values. R is equal to small y minus capital Y are called residuals, or they are the approximate errors. Now there are three types of problems in curve fitting. The first one is fitting of a straight line y is equal to ax plus b. The second one is fitting of a curve y is equal to ax raised to b. The third one is fitting of a second degree parabola y is equal to ax square plus bx plus c. In this presentation, we will discuss specifically about the curve of the form y is equal to ax raised to b. We now move on to the procedure. Here, the first step is we have to write the normal equations corresponding to the curve of best fit. The second one is we have to present the relevant table and find the value of all the summations present in the normal equation. Third one is we have to substitute these values in the equation with unknown parameters. Step 4 is we find the parameters and then substitute it in the system of equations y is equal to f of x, which being the curve of best fit. Now let's talk about the fitting of a curve of the form y is equal to ax raised to b. Here we take the logarithms on both sides to the base e. So we have log y to the base e and equal to log a to the base e plus b log x to the base e, because log of x raised to n equal to n log x. And then we substitute it with unknown parameters. Capital Y is equal to capital A plus capital B into capital X, where y is equal to log y to the base e, a is equal to log a to the base e, b is b, x is equal to log x to the base e. Then we associate normal equations. Summation y is equal to n capital A plus b summation xy is equal to a summation x and b summation x square. We solve the equations 2 and 3 and thus we obtain the unknown parameters. After we have found the values of the parameters, we then find out the values of the variables. In this case, we have found the value of capital A, which is an unknown parameter, and then subsequently, because a is equal to log of log of small a to the base e, we find out the value of variable a. We substitute the values of a and b in y is equal to ax raised to b, and thus we get the curve of the best fit in the required form. Here we can use this procedure to find the fit for the curves of the form y is equal to ae raised to bx and y is equal to ab raised to x, etc. Let us now move on to the example. The question is, fit a least square geometric curve y is equal to ax raised to b for the following data. And here in the table x equals 1, 2, 3, 4, 5. For the corresponding x, we have y equals 0.5 to 4.5. Here, as we have seen earlier, we take log on both sides. So log y to the base e is equal to log a to the base e plus b log x to the base. unknown parameters. So let y is equal to log y to the base e, a is equal to log a to the base e, and x is equal to log x to the base e. Now the normal equations are summation y is equal to na plus b summation xy is equal to a summation x plus b summation x square. Here n is equal to 5. Then we create the relevant table, which you can see here. X and y values are already given in the question. Then capital X, which is our unknown parameter, which is equal to log of x to the base e. For that we have substituted the values of 1x, 1, 2, 3, 4, 5, and we get the values of log of x to the base e as 0, 0.6931, 1.0986, 1.3863, 1.6094 respectively. Similarly, we have calculated the values of capital X square. Here capital XY values are calculated by multiplying the values of capital X and capital Y. Basically we are multiplying log of x to the base e into log of y to the base e. Then we calculate x square, capital X square, by squaring the value of log of x. Then we find out the summations for each of the following cases for capital X square. So then according to the procedure, we substitute the values of the summation in the normal equations, and in this case, in this example, we receive 5a plus 4.7874b is equal to 6.1092. The second equation is 4.7874a plus 6.1993b is equal to 9.0804. By solving these two equations, we get capital A is equal to minus 0.69315. Capital A is our unknown parameter, and capital A equals log of A to the base E. We have also got B, which is equal to 2. Considering B, capital B, which is our unknown parameter, is equal to 2, and as we have seen at the starting of the question, capital B is equal to small b. Therefore, small b, which is our variable, will be equal to 2. In the case of small a, which is our variable, small a is equal to e raised to capital A, which is equal to e raised to minus 0.69315. Using a calculator, we get the value. We substitute the values, and thus we get y is equal to 0.5 x square as the required curve of it. As we come to the end of the video, I'd like to thank you for watching the video.